Hello everybody, and welcome to this special session dedicated to the nuclear sector. I am very glad to have with me for the next 30 or 40 minutes three experts in this area. Mr. Theodor Chirica, member of the board Nuclear Electrica, Mr. Alan Woods, representative of Rolls-Royce, the SMR division, and Ms. Madalina Coca from Cenecan, Romania. Will be talking about two or three themes very topical at the moment in Romania and in Europe. And the first one is is about what I called the last wave of large reactors, nuclear reactors. This formula seems not to be enjoyed by everybody, so if you consider it wrong, please dispute it. We're also talking about SMRs, the promises, the difficulties, the challenges, and maybe the next steps in order to have this new technology implemented in Europe, in Romania, and throughout the world. So if everything is okay technical, I will give the floor now to Mr. Theodor Chirica for the first intervention. Please.
Thank you very much. So, yes, I was on those not very happy with the topic. It's hard to say that we are at the end of the large-scale reactors before the nuclear to move to SMRs. Just remembering that there are about 100 units planned and about 55 nuclear units under construction, from 700 to 1,800 megawatts, commercial after 2030, and in operation by 2090. So that is practically is not an end of the large-scale reactors. Because during the transition towards 2050, the nuclear power will rely on LTO. LTO as a part of this transition. LTO programs consider the life extension for the existing unit with 30, 40 years, in some jurisdiction 60 to 80, as a bridge to future technologies. Romania is part of this trend, and just I'm remembering the major projects as Cernavoda refurbishment and life extension, completion of Cernavoda 1, completion of Cernavoda 3 and 4, and SMRs after 2030, 2035, that they will be complementary to the nuclear energy together with the Cernavoda units. I can note a project which is in incipient phase, is not belongs to Nuclear Electrica, is Alfred project, generation 4 SMR, lead cooled, Romanian-Italian cooperation under development at Nuclear Research Institute in Pitești, and also another important project which is connected with mainly with Nuclear Electrica projects is the disposal facility for low and medium radioactive waste. We see in our approach, talking now about power, a great potential in Romania for both large-scale reactors and SMRs under a North Atlantic cooperation that mentioning United States, Canada, France, Italy, and any others, with local developers and industry. Large nuclear power plants are already proven technologies, adding security and stability to the national and regional grids, while SMRs are representing the response of the nuclear industry to the increased flexibility requirements of the grid, suitable for more non-electric applications, such as cogeneration, serving small to medium-sized communities or isolated human settlements, desalination, or hydrogen production. They are bringing a simplified design with enhanced nuclear safety features and robustness. Both are part of the solutions to reach the climate objectives of carbon neutrality by 2050, together with other low-carbon energy resources, mainly renewable. There are some challenges for first-of-a-kind SMRs, but they are taken over by modularization, standardization, and simplification. As advantages for SMRs, and I do not insist too much because we have experts in SMR here, we can mention lower construction costs, reduced land use, and increased opportunity for local supply chain where they will be deployed. Certain SMR challenges can be mitigated by worldwide harmonized licensing frameworks requiring a strong alliance utility regulator. So I expect that Madalina will tackle with this topic. Robust supply chain achievable to an alignment of several states, mainly for middle-sized or small states, focusing on a certain, jointly focusing on certain type of SMR, and of course, a qualified human resources available to embark in such projects. As far that we discuss about the human resources, and part of the topic is regarding the new generation of experts in nuclear. I can just touch a little bit the nuclear electrica efforts for talent recruitment and retention. Existing human competencies and skills can be easily shifted towards the new technologies, while new generation of specialists must be trained through a dedicated educational system. The challenge for the development of nuclear project is to ensure a skilled workforce, retain talents, and ensure the transfer of knowledge. We have a strong preoccupation regarding talent recruitment and preservation in view of large investment projects. Now we are performing a recruitment program, a large recruitment program. Now we have 100 jobs, and for the first phase for the Unit 1 LTO, as part of the job dedicated to graduates and no experience, with no experience requirements. So we received more than 300 CVs for this. So that seems that nuclear is not is still desired as a job. Of course, we launched a dual education program in cooperation with technical or vocation schools in different high schools or vocational schools around Cernavod town, in Cernavod, Fetești, Medgidia, extending cooperation with University of Constanța for employment of about 30 engineers of different disciplines. And of course, we consider cooperation with the Polytechnica University of Bucharest, with the Faculty of Physics from the University of Bucharest, and also with University of Pitești. During this year, we will continue the scholarship and internship programs dedicated to undergraduates and graduates, including summer apprenticeship at the plant in order to offer hands-on experience. So that is something that I can say about this topic. Of course, that we continue with mentoring programs, reducing the personal fluctuation, and of course that the talent retention is a very, very important subject. At the end of the day, we believe, just as the end of my presentation, that state has a role, so must have a role in supporting and developing nuclear energy, identifying among others the following directions: education, investing in technical and digital education, strengthening the system of technical education and retraining to the today industry's requirements, encouraging postgraduate training, including Master of Science and PhD degrees, with the objective to retain skilled workforce and to increase the competitiveness of the national industry. That's important is the movement of workforce between sectors has to be encouraged, as there are valuable industries with qualified manpower, some of them no more compliant with the new environment requirements. Nuclear research is an important direction that the government has to be involved, and also to support the applied research in partnership with industry for the development of industrial technology involved in the nuclear program. As a business environment is important by government-industry partnership dedicated to increase productivity, facilitating affordable financing for these activities, as well as stimulating investors to the domestic market to appropriate measures for using local opportunities. In my opinion, a major upgrade of the country industry is necessary, and nuclear
is a part of this progress. Finally, the reference document that I used for this part of my speech is the Industrial Strategy Nuclear Sector Deal, part of the UK Industrial Strategy launched in 2018 and evaluated after 2 years by UK Nuclear Industry Council in September 2020 under the title was Nuclear Sector Deal 2 years on. I conclude quoting the US Nuclear Energy Institute President and CEO, Maria Korsnick: "The nuclear energy is the source that can make it all work, not just electricity production, but job creation, economic revitalization, and decarbonization." Thank you very much for your attention.
Thank you, Mr. Chirica, for your first intervention and for this passionate plea for the energy industry. It is nothing less of what we expected for this start in our conversation. I will now give the floor to Mr. Alan Woods, Director of Strategy and Business Development for the SMR branch of Rolls-Royce. Mr. Woods, how is your view? How do you see this competition, or is it a competition between large reactors and the SMRs at the moment, maybe in the future?
Sure. So, well, first of all, thank you for giving me the opportunity to speak today. It's a great pleasure to be here. Just as way of background, I think it's useful for me to explain to people the background of Rolls-Royce. Rolls-Royce has actually been designing, manufacturing and operating nuclear power plants for 60 years now. And we do that for the UK government, the UK submarine programme. We have also been operational in the civil nuclear industry for a large number of years. So we have not just a background in cars and aviation, but also a strong heritage in nuclear as well. So to address the question of why SMRs and your question about particularly with respect to large plants, I'm not sure whether it's an either or, but what SMRs can do is play a role across a broader spectrum as the energy environment changes around us with decarbonisation. If we look at the future world, our view is that we'll no longer see different markets of power, heat and transport, but these will be merged as we seek to decarbonise power and transport, heat and transport sectors, and we introduce technologies such as hydrogen, such as synthetic fuels. All of these will require more clean electricity to help generate them in many of the available technologies. And SMRs can play a strong role here because they are of a better size. They can also play a strong role as we seek to decarbonise the power grid, because they can sit in existing locations, they can be sited in more remote locations, and they can integrate more quickly and effectively with existing grid networks. So we believe SMRs can play a very strong role, as can nuclear in this future energy mix. But the challenge for nuclear has to be addressed. And when we started designing our SMR, we started from the principle of what is the problem we're trying to solve? And the problem that we're actually trying to solve is making nuclear investable and deliverable. And by investable, we mean making it of a capital cost level which can be invested in by private industry. So we don't need governments to constantly sit behind nuclear new build programs. And by deliverable, we mean that we will do what we say we will. We will deliver it on time and we will deliver it on budget. So our program is entirely focused on solving this problem. And therefore, where we introduce innovation, we do it for benefit. We're not introducing technology just for the sake of it. And in doing so, we're focused entirely on reducing the capital cost, the operational cost, reducing the time to build, and crucially, eliminating risk from traditional nuclear. So our approach has been to turn nuclear from an industry where new build is very large, one-off infrastructure projects to a standard, repeatable, factory-delivered product. And that is the basis of our power plant. So let me just talk about the S, the M, and the R, because I think this is very important to put in context. When we talk about S, it's often spoken about in terms of power level. Actually, our approach for the S is about optimizing the power, maximizing the power within a constraint of physical size. And our physical size is driven by a requirement to be road transportable, so we can access those many sites. Within that, we want to optimize the power. It's no good us designing a 300 megawatt power plant if it's the size of a large reactor. That wouldn't work economically. So next point is the M, the modularity. This is not, in our view, a question of how big a single one-off module can we make. Modularity is about manufacturability, it's about repeatability, about commoditization. It's about designing the product to be manufactured in factories on a production line and designing those factories to manufacture the product. It's the same way we do it in our other industries in Rolls-Royce. It's the same way we're doing it for our SMR. And finally, the R, the reactor. The nuclear industry has an obsession with reactors, but we operate in a world where our customers want power plants, and therefore we have to design an integrated power station. The reactor is only about 20% of the capital cost, 20 to 25%. So our approach is to design a full integrated power plant, and modularity applies to the whole power station. So we modularize not just the nuclear island, the balance of nuclear island, the balance of plant systems, but also the civil structures. All of our power station above ground is factory fabricated, including those civil structures. And that allows us to reduce risk, reduce capital, and reduce build time. So finally, what do we offer as a company as well? Actually, we are a manufacturing company, and our business will deliver the full turnkey power plant solution. We'll manufacture it, we will install it under our weatherproof canopy at the site, and we will commission it. That is our business. We will provide that full end-to-end service. So just a final touch on our current status. It was mentioned by the previous speaker of the UK's industrial strategy. As part of that UK industrial strategy, Rolls-Royce is working with the UK government on the design and licensing of our plants. We're just moving into the next phase where we will be forming our special purpose vehicle company that will take this forward alongside the UK government with government funding, and we will be entering the licensing process this year in the UK. We thoroughly look forward to opportunities to work with Romania and Romanian partners. As I say, our plant is a product, and therefore we have to work with partners to deliver that product. It's not a one-off infrastructure program, and that's where we will seek capable partners who are willing to participate in the program. So thank you very much, and I look forward to taking any questions.
Thank you, Mr. Woods, for your input in this conversation. I am just reminded of one of our comments a few years ago in one of our large events at the end of the year, one of Energynomics gala, when we prepared a very elaborate movie where one of the lines was something like, let's prepare for the future when we have access to small, personal, infinite source of power. And maybe technology is one step at a time advancing towards this dream. But I will now move to Ms. Madalina Coca, representing the regulator on the nuclear sector in Romania, for a quick overview of how is Romania prepared, ready to use, adapt, welcome such technologies. Please.
Thank you. I would like to speak about the regulatory framework that has been established by CNCAN, and how is this prepared for the licensing of SMRs. I am trying to share my screen. Oh, the participant screen sharing is disabled. So I will just talk freely. In 2019, we have revised our regulations on licensing to include also small modular reactors. Our regulatory framework is technology neutral, and it includes the requirements for compliance with international standards and high-level nuclear safety goals that have been established in international standards and in European legislation. So from this point of view, we do not have any particular requirements that would hinder licensing of new reactors in our country. We can benefit from the regulatory reviews performed in other countries, for example, US, UK, Canada, countries, France, which have very well developed regulatory frameworks and very competent regulatory authorities, the processes of which we are aware of and we trust. This would help us speed up the licensing process. So in case new reactor design that has been already reviewed by a regulator in these countries and has been found acceptable, has greater chances of passing through a easier review in our country, because our regulatory framework is not so different from the regulatory frameworks in these vendor countries. Also, our licensing process normally starts with a design review. So far, the design review has been part of the licensing for the siting, construction, and operation stages, but envisaging the possibility to license new reactor designs in the next years, we have introduced in our regulations also the licensing phase for the design. It is similar to a design certification or a design approval process in other countries. So far we have not tested this process yet, because we did not receive any new application for a new reactor design to be constructed in Romania, but we are expecting to see such an application in the next few years. So apart from the regulatory requirements at national level, we have to comply also with the requirements in the Nuclear Safety Directive issued by the European Council. And this imposes high safety goals that have to be met by all the reactor installations in Europe. These safety goals have been translated into our legislation, and when reviewing a new reactor design, we will look into the safety analysis and also into the experimental basis for the design requirements and design assumptions and safety analysis assumptions. So our regulatory review follows a top-down approach, where we first look at how the high-level requirements are met, and then go down to system level and component level and look into the technical details. So this would conclude my presentation, and I look forward to any questions that you may have.
Thank you, Ms. Madalina Coca, for your input. We solved the problem with sharing the presentation, but we probably have access to it and present it in our website in the near future. Thank you very much for your comments. One more question in just a few minutes maybe on this issue of SMRs. Are there any different technologies under this umbrella, this name? I know that Nuclear Electrica already signed some MOUs in order to be part of such projects. If you can make a short comment on this, please, any one of you.
Well, I will start by saying that I've seen that there are many technologies available for small modular reactors. So there are international reports on these technologies available, and the variety seems to be larger than for the current reactor designs, which are now in operating nuclear power reactors. But in our case, we have not yet received an application for a design review. We know that Nuclear Electrica has signed a memorandum of understanding, and I think it's with a new scale design. but so far we have not received a formal application to perform a regulatory review of this design. So maybe Mr. Chirica can tell us more. Thank you.
Please, Mr. Chirica, if it's the case.
Yes, the new technologies like SMRs are contemplated by the intergovernmental agreement between the United States and Romania as an option, because you know such intergovernmental agreements, they are contemplated different options. And of course that still at this moment seems that the new scale is quite advanced, but I'm afraid that they not have yet design license from the American regulatory body. So at the end of the day, it's almost all the projects are in the same status. Maybe Alan can tell us more where is Rolls-Royce with this. We do not have in this moment a strong dedicated team for implementing tomorrow or the day after tomorrow an SMR. Now we are contemplating, we are evaluating different technology and following the progress of different technologies. So it's in our strategy, we are considering SMRs to be ready after 2030, maybe 2035 in our case, because meanwhile, imagine that we have practically, we get a little bit overcrowded because of some delays, not because of nuclear electric, those delays, but we have the life extension of Unit 1, which is not an easy project, because we have to work under radiation conditions, we have to dismantle. You know, in a CANDU is not as, it's a little bit more complicated at the PWR or BWR. Practically, we dismantled the active zone of the reactor. And then we have also Chernobyl 3 and 4. We have the tritium removal facility. So practically today and in the next 5 years or more, I do not see nuclear Electrica embarking in a SMR project. And they are also, in our opinion, they are not already cooked to be put on the table and to serve from them.
Thank you, Mr. Chirica.
But of course, we have to see what's happening in the future.
Yes, yes.
We have to see where the trends are. Of course, if you ask me, I'm an old generation. I rather prefer light water or heavy water reactor. I'm more familiar with them rather than a molten salt or some other. Okay, I'm ready. Still, I'm ready to learn and to better understand and other technical approaches.
Thank you, Mr. Chirica. I turn to Mr. Woods with a short comment on different types and of SMRs at the moment.
Yeah, I think the last time I counted, there was well over 100 different SMR designs around the world have been proposed. We started from a blank sheet of paper and we considered all technologies. And we're still looking at technologies, future technologies such as molten salt. But I come back to the point I raised in my presentation. What problem are we trying to solve? And right now, the problem the nuclear industry has is cost and schedule. And the fact that trying to build a power plant constantly relies on government sources of funding and lots of funding, very high capital for large plants. So our plant is a PWR for a lot of the reasons already stated. We need to have something which is compatible with existing licensing regimes, doesn't introduce challenges that have never been seen before. It's compatible with existing infrastructures around the world and capabilities around the world. We don't want to introduce a technology which needs completely new fuel routes or waste routes to be built alongside them. That's just more and more cost. But critically, our focus is designing a power plant which can be commercially deployable, funded by industry, if you like. What we can't afford is to have to run a prototype for 5, 10, 15 years to demonstrate the product before we can commercially sell one. We can never make a business case on that. That's why ours is a PWR. I'll come back to the point I raised at the end as well. This is a power station. It's not about the reactor technology. We have to innovate where innovation drives benefits in terms of cost reduction, schedule reduction, risk reduction. We should not innovate that actually introduces risk or introduces time to build. That would be the wrong way to do it. Doesn't mean that future technologies may come along, but until we can pinpoint what problem they're genuinely solving, I'm not sure why they would be considered right now.
Thank you for your comments, the three of you. And as we have, I don't know, maybe 7 to 8 minutes, I would be interested in, I hope that our audience also would be interested in a short perspective from your side on the EU taxonomy. Is the looming subject for many months already, and I don't know if any changes occurred in the last few weeks or months that would be relevant for the nuclear industry. Please, Ms. Coca, maybe start.
Well, thank you, but I'm not very familiar with this subject because this is something of interest primarily to the promoters of the nuclear reactors, to the industry. So I will let Mr. Chirica answer this question.
Okay, Mr. Chirica, please.
Yes, taxonomy is, how to say, my last time preoccupation I'm spending in the last half year. More than 50% of my working time concentrated on taxonomy and cooperating with European industry in this respect, and trying to inform as correct as possible the politicians, the parliamentarians, and the commission, if it's possible, to convince the Commission. The taxonomy, there are some promises. You know, I don't want to take the back history regarding the technical experts group report on taxonomy, and regarding nuclear, they say, okay, as operation, nuclear is okay, but we are not able to evaluate especially the end part of the fuel cycle, meaning the disposal of spent fuel. And they asked the Commission to take somebody else. Fortunately, the Commission took a good decision. They have their research arm, which is GRC. And GRC, the patent group, they did a good report and a neutral report, but saying that is not a big difference between the impact on the climate, on the nuclear, compared with hydropower or other renewables. Regarding the radiation effect and contamination expert, they say that there are risks that they can be managed, they can be under control. So practically the GRC report is positive. Now we are waiting for there are two committees that were in charge by the Commission to have an independent evaluation of GRC report. The first one is the Article 31 from the Euratom Treaty, and they are professional. I know some of them, and they are professionals, they are experts in waste management. And there is another, is a shared group from DG Sante, and they are more experts on medical and radiation effects against the human being, human body. So it's, they feel it, but we do not have information from inside that is good or bad, or is neutral, or we expect to be professional, that report. Of course, yes, it's well known that it's a fracture between the nuclear like-minded member states, and the member states are not liking nuclear, and practically the debate is more political and ideological rather to be a scientific-based and technical-based debate. In this respect, take advantage that Aran is here. For the nuclear-like-minded, Brexit was not good at all because we lost a strong, there were two strong pillars, France and the UK in the European Union. Now it's France versus Germany.
Yes, a hot topic in the European Union, not so much for the UK-based Rolls-Royce, but maybe if are there any operations Rolls-Royce is undergoing in Europe. I don't know if this is a subject for you, Alan.
Well, Rolls-Royce is a global business. Across our group, we've got many facilities across Europe as well as the rest of the world. I don't really want to get drawn into Brexit. It's been quite a painful experience, and it continues to be so. Just on the taxonomy and the green issue, I think there's, the nuclear industry is collectively, we do need to start being a little bit more outwardly focusing with all of the good things that we do as an industry. From a cost perspective, we include all of the costs of building, operating, decommissioning our plant. We have to demonstrate how we're going to handle all of the waste before we even put a spade in the ground. That's the requirements that are set on us as an industry. And I'll just leave a thought on this, which is if every other industry in the world had been required to do that from day one, we wouldn't even be talking about net zero right now. Nuclear industry always has and remains to do that. So I think we deserve some recognition from that. But I echo previous thoughts. This is very political, and unfortunately, nuclear will remain that way.
However, what is interesting that now there are also other taxonomies developed in different countries. UK understood that they are now developing a taxonomy. United States, Russia and China, they are working on their taxonomy. So practically at the end of the day, you have to see what's the Europe to be an isolated island in the ocean of the nuclear. You have to see what's going on. I'm sure that the rationality will win at the end of the day. And that is very important. I mentioned the North Atlantic cooperation. So just at the end of the May, the Minister of Energy from the United States and the Minister of Energy of France, they signed a joint statement regarding supporting nuclear energy. So that is a very important step outside of the borders of the European Union in this respect.
Mm-hmm.
Thank you all of you. It was a very short session this year, but a very focused one, and I'm very content with things that I heard today, and they are openings for future conversation. I hope that you will answer our calls in order to develop more these subjects and others like this in Energynomics.ro maybe. So gentlemen, lady, thank you very much for today. Please join our Energy Strategy Summit for the rest of the day, if possible. If not, the recording will be available in Romanian and in English from today on. That was the special session dedicated to the nuclear sector this year in our event.